In section 4.1, part 2, we're going to pick up exactly where we left up on our first part with this tableau that we made from our linear constraints, which are the first two rows, and our objective function, which is the last row. We need some terminology here just so we can communicate back and forth. So we're going to call these columns over here basic columns because they've been transformed into what we consider to be unit columns with ones and zeros. So these basic columns are already unit columns. These two are not, because they're not made up of ones with zeros in them no matter what. So these are not basic or not unit columns. If we were to pick the solution off right now, which your book refers to as a basic solution, anything that's a unit column would be a solution. Anything that is not a unit column is assigned a value of 0. So in terms of the x, it's going to be 0 because it is not a unit column. Same with y, it would be 0 because it is not a unit column. But when I get over to u, the u column is already made into a unit column because it has a 1 followed by zeros. So 1, this 1u would be equal to the 3200. The v would be equal to, again, it's a unit column because it has a 1 and 2 zeros. So that v would be equal to the 520. Notice the profit's also a unit column already. So over here, our profit would be equal to 0, which this should make sense in terms of the dining tables and chairs. If you produce no tables and you have no chairs and all the slack is taken up by sitting in the warehouse, basically, of your labor hours and your board fee, then you're not making any profit. So the solution actually does make some sense in terms of the words. So what we have to do is now start transforming this thing. And in order to transform it, we first need to decide on the pivot column and then the pivot element. So step 1, to find the pivot column. So we're going to look at the last row and pick the column with the most negative number. In other words, which of those numbers lies to the furthest left on the number line? Well, my numbers are negative 45 and negative 20 and 1. Negative 45 is the furthest to the left. That's our pivot column. To pick the pivot element, and again, our pivot element is what we're going to want to turn into a 1. And that comes way back from when we first started Gauss-Jordan. To find the pivot element, we're going to look at those ratios of taking the constant and dividing it by the coefficient. So we need to look at the ratios of the constant over the coefficient. And we're referring to the coefficient in the pivot column. That's why you have to do that part first. So if we come in and take a look at those ratios, we're taking the 3200, that's our constant, and we're going to divide it by the coefficient that's in the pivot column, that's the 40. And that would be equal to 80. Sorry, that's a little squished in there. For the next row, we're going to take its constant of 520. We're going to divide it by its coefficient in its column, which is a 3. And 520 divided by 3 is 173. And if you remember those two numbers, those were the x-intercepts off the graph of the two constraints. And we picked the smaller one. So look at the ratios, pick the smaller one. So the smaller ratio is this 80. And that then tells me that my pivot element that I need to make into a 1 is this 40. So let's backtrack through that again. I have to decide which column I'm going to manipulate. To do that, I look to see which is the most negative number I have, which is this guy. Once I've picked the column out, I then have to figure out which of the two elements we need to come in and transform. To do that, we're going to figure out the ratio of taking the constant divided by the coefficient, the second constant divided by its coefficient, and picking the smaller one. So we now know our goal is to make this 40 into 1, and then we're going to make that x column into a unit column. We need 1 followed by 2 zeros. And this is where our Gauss-Jordan pays off. We've learned how to do it. So the process here should be straightforward. So we want to make that 40 into a 1. We're going to come in and do 1/40th of row 1. And I'm going to use a squiggly line to separate my different tableaus just to help us keep track of everything. So if we come in and divide this by 40, we're going to get a 1. We'll end up with 16 over 40, and 16 over 40 is 2 over 5 once I've reduced it. 1 over 40, 0, 0. 3,200 divided by 40 is 80, which we recognize. I'm going to copy over the remaining rows, 3, 4, 0, 1, 0, and 520. Next, we'll have a negative 45, a negative 20, 0, 0, 1, and 0. So our 1 is where we need it to be. But we want the X to be a unit column, so that means we're going to come in and we need to make the 3 into a 0 and that negative 45 into a 0. To make the 3 into the 0, we're going to do row 2 minus 3 times row 1. So if we take 3 minus 3 times 1, we'll get a 0. To make this guy into our 0, we're going to take row 3 and add 45 times row 1. So that would be negative 45 plus 45, which is 0. So that'll give us this, x, y, u, v, p, and a constant. We're not changing that first row, still a 1, the 2 over 5, the 1 over 40, 0, 0, and 80. Okay, we come in and do row 2 minus row 3. We're going to end up with 3 minus 3, which is 0. 4 minus 3 times 2/5 gives me a 14 over 5. 0 minus 3 times 1/40 is going to give me a negative 3 over 40. We have 1 minus 3 times 0, which is 1. We have 0 minus 0, which is still 0. 520 minus 3 times 80. 3 times 80 is 240. Subtracted from the 520 is 280. So you're going to see some fractions popping in here. Okay, the negative 45. So to make this into a 0, we're doing row 3 plus 45 times row 1. So negative 45 plus 45 is going to give us a 0. In the next column, we're going to have our negative 20 plus 45 times 2/5, which gives me a negative 2. The next one, we have 0 plus 45 times 1 over 40. It gives me 45/40, which is 9 over 8. We have 0 plus 0 is 0. 1 plus 45, times 0 is still 1. And then finally, we have 0 plus 45 times 80. So 45 times 80 comes out to be 3,600. And now we have our unit column. So if we wanted to pick off the solution right now, we look at the things that are unit columns. So here's a unit column, here's a unit column, and here's a unit column. So we can see that X would be equal to 80. And again, that's this one X equal to this 80. Y is 0 because it's not a unit column. U is 0 because it's not a unit column. V is 0. V is equal to 280. And our profit down there at the bottom is 3,600. Which, if we go back to the graphical approach, we're at the x-intercept 80, 0. 80 times the 45 that was the profit on each table was that 3,600. So we're getting the same answer we got when we graphed it and found those corner points. There's that first corner point that's at the x-intercept. But we're not done. We know that that's not the profit. We know that's not the maximum. So how do we know we're actually not done, though, from this over here? Well, because we still have a negative in the bottom row. So it's important to know that our goal is no negative number in the bottom row. And that's how we know we're done with the row manipulation in the bottom row. No negative number in the bottom row. So we'll come back over and repeat the process again. So to repeat the process, we have to figure out which column to work on. This time we only have one negative number to worry about, so this is automatically our pivot column. We need to figure out the pivot ratio. Which one are we going to do? The 2/5 or the 14/5? So to do that, we take the 80, that's the constant, divided by the coefficient. So I'm going to divide that by 2/5. So that really becomes 80 times 5/2, which is 400. Nope, 200. Sorry, I did that wrong way. We're then going to come in and take our 280, dividing by the coefficient, which is 14/5. And that one comes out to be the 400. Oh, that one comes out to be 100. And we pick the smaller one, which is this guy, which means that this is our pivot element right there. Okay, I've obviously run out of room on the board again. So I'm going to come in and transform this one moving up. Get rid of all of that. So again, our goal is to make this 14/5 into 1. So to do that, we're going to do 5/14 times row 2. I'm not going to touch row 1 or row 3, so I have my X, my Y, U, V, P, and the constant. So the first row stays as a 1, 2/5, 1/40, 0, 0, and 80. The next one then would be 0 times 5/14 is 0. 14/5 times 5/14 is 1. Negative 3/40 times 5/14 comes out to be negative 3/12. We then have 5/14 times the 1, so 5/14. Then we have 0 times anything. 280 times that 5/14 is going to give us a 100. And we'll copy over the bottom row because we did not manipulate it. So 0, negative 5/2, 9/8, 0, 1, and 3,600. Whew. So all that's left to do is to take that pivot column and make the rest of the entries into zeros. So again, what we're trying to do is to make the 2/5 into a 0. And we're trying to make that negative 5/2 into a 0. Okay, so to do that, we're going to come in and take row 1 and subtract 2/5 of row 2. So that'll give me 2/5 minus 2/5, which puts a 0 there. Down here, we'll do row 3 plus 5/2 times row 2. So, oops, sorry, that's a negative 2. That was my mistake. That should be a negative 2. Let me double check to make sure that everything else is correct. So 0, negative 2, 9/8, 0, 1, and 3,600. Yeah, that makes it a lot easier. Not as many fractions to manipulate. So we're going to add 2 times row 2. So row 3 plus 2 times 1 would give me a 0. So that's going to give me as 1. 2/5 minus 2/5 is 0. I have 1/40 minus 2/5 times that negative 3/12. That's going to give me 1/28. I have 0 minus 2/5 of 5/14, which is a negative 1/7. And we have 0 minus 0, which is 0. We now have 80 minus 2/5 of 100, which comes out to be 40. The second row is fine the way it is. And then finally on the bottom row, 0 plus 0 is still 0. Negative 2 plus 2 is 0. The 9/8 plus 2 times 3/12 comes to be 15/14. 0 plus 2 times 5/14 is 5/7. 1 plus 2 times 0 is 1. And 3,600 plus 2 times 100 is 3,800. Whew. And how do we know we're done? Because there are no negatives in the bottom row. So this tableau is in its final form. All we have to do is pick off our answers. So the basic solution, X is a unit column, so this X is equal to 40. Y is a unit column. Y is equal to 100. U is not a unit column, so we assign it a 0. V is not a unit column, so it gets a 0. And then finally, P, the profit down here in the bottom, is equal to 3,800. Now remember, these were the slack variables. So our solution then is we're going to make 40 tables plus 100 chairs for a maximum profit of 3,800, which is the same answer we got when we did it with the graphing